Hi guys, my name is Daniel. I'm the tech guy behind the AstroPrint service and the AstroBox. And we wanted to make this video because we wanted to share with you some of the tech details of creating these services. And we realized that not everybody needs to hear this. I mean, we make this product to be non-technical, really simple to use with an amazing out-of-the-box experience. But if you are inclined to know what's inside, how it was made, and what is it made of, then I invite you to come along and watch me on this video. So the first thing I'd like to talk about is our decision to use PC Arduino 2 versus Raspberry Pi. And for that, I'd like to start by showing you our first prototype of the AstroBox. This is based on a Raspberry Pi board, as you can see here. And the first thing you'll notice is it made for a really awkward box design because there's all these things sticking out. First thing is a Wi-Fi module. We couldn't actually use an inbuilt Wi-Fi module because the board didn't have one, so we had to add a USB one. Also, the SD card is kind of awkwardly sticking out of the box, and there's a bunch of things here that are not used for our use case, but they still are part of the board. So, you know, it didn't really match our design expectations, and in addition to that, the board seems to be like 1 or 2 generations old in terms of computing. It uses a 750 megahertz processor. It has 512 megabytes of memory, and it's an ARM v6 architecture, which basically means you're not really future-proof. So with that in mind, we decided to go and search for other alternatives, and we came across the PC Arduino 2. PC Arduino 2 is an ARM v7 architecture based on a Cortex A8 chip with a 1 gigahertz processor and 1 gigabyte of memory. This board has a built-in Wi-Fi, which allowed us to make this really cool looking box with nothing sticking out and a really, really good use of power. Another problem with the Raspberry Pi was that if you have a 1000 milliamp power supply, the Wi-Fi module could actually suffer. In some cases, with degrade network performance. In extreme cases, would actually stop the board altogether. With this, there is a 2000 milliamp power supply that comes with the box, and it allows for awesome network performance and a very, very fast computing platform. Being an ARM v7 architecture allows us for future-proofing our software, which means we'll be able to add new versions of Ubuntu as they come along and take advantage of some of the new features that will come with them. So all in all, we're really happy with our decision. This is a very, very fast computing platform. It has 4 gigabytes of memory built in, as well a 8 gigabyte MMC card that we ship with. So as far as the software stack on the AstroBox, we run on Linux Ubuntu 12, and what we've built is a heavily modified version of AstroPrint. And AstroPrint, as you may know, is a Python web server that uses a server code to talk to the printer through USB and also to serve web pages to a computer. So we modified the UI to make it really beautiful, easy to use, and mobile-friendly interface, as well as we connect it to our AstroPrint service to allow for super fast cloud slicing and design files, storage, and organization of your G-code file as well. So let me talk a little bit about the AstroPrint service. AstroPrint ran on Amazon Web Services server farm using high CPU instances. We have put Slicer on the cloud on a very fast CPU computer that can take the thread feature of Slicer and basically take a slicing job and split it into different parts and run them in parallel. That allows you to have very complex models sliced in a very, very short amount of time. In addition to that, we take the G-code files and put them on an S3 bucket with some metadata. For example, what settings did you use, what printer was it for what filament, and what quality did you want to print that on. This allows you to then go back and check for each design file which G-codes you have already generated so that you don't have to slice them again. For example, you can go back and say, I want, for my octopus, I want to take the file that was generated for my Airwolf 3D for PLA in high quality. You can then retrieve that and print it right away. One of the things we really wanted to do was to make a really good out-of-the-box experience. When the box first boots up, it's going to create its own Wi-Fi network so that you can then, using your phone, configure it to talk to your home or office Wi-Fi. After that, the box will just become another computer in your network that you can access through its web address, which by default will be astrobox.local, but you can also change that. Once you have it connected to your network, you can then access your box from anywhere in your network, in any device, with a simple web browser. The box will then talk to our AstroPrint service and allow you to slice and retrieve your previously sliced files, as well as allow you to talk to the box from anywhere outside of your local network. Anywhere on the internet, you will be able to talk to your box once it's connected to your home Wi-Fi. This will allow you to see the progress of a print that you can then stop, pause, resume, change settings on the fly, or any of the other things you could do from your local network. The software that goes in the AstroBox is open source, and we're really hoping that you guys contribute. You can request features, you can fix bugs, or you can improve it. We're really looking forward to working with you on this, and we feel that this is what the 3D printing industry right now needs to make 3D printing really awesome and work for everybody. Thank you so much for listening, and we hope you enjoy your AstroBox. And now, what I'm going to do is what every good coder does. I'm going to turn beer into code.